logistic regression. Then if you are making use of any algorithm, right, whatever the algorithmic aspects we're having, those algorithms are basically comes into the category of, especially in the supervised, we are having classification and as well as the regression. Classification, which is giving yes or no kind of thing, or else true or false, 0 or 1. So these kind of the observations will be getting from the classification. So in terms of logistic regression also, okay, just we are making use of this logistic regression to get the yes or no aspect. Though the name regression is there, but still it is focusing on the classification thing only. Okay, so now let us see what exactly the basis for this logistic regression and how we are making use of the convention of understanding the logistic regression. See here, guys. So I have compiled this particular information for us so as to discuss. Just you observe here. Logistic regression, which is a technique borrowed by machine learning from the field of the statistics. Always one important point we need to consider, guys, like the statistical methodologies or stats. Uh, so this particular stat information in terms of metrics or in the summary of the data, exploratory data analysis, in all these kind of the things, definitely we have to use the statistical analysis, friends. Okay, and if you are able to identify the background logic of that stat model, it is easy for us to understand the insight of the algorithm. Maybe in terms of, if I'm talking about the naive Bayes or support vector machine, decision tree, random forest. In terms of naive Bayes, we're having the Bayes theorem, all the weak learners, and we are combining that. In terms of support vector machine, we are having the kernel trick. Okay, which is making use of the margins and all. In terms of the decision trees, we are having entropy, information gain, all these things. Whereas in the random forest, it's a kind of technique where we are keep on adding some sort of the decision trees and is an ensemble based kind of the technique. So especially in the machine learning, uh, while talking about the algorithms, definitely some sort of the mathematical or statistical implication would be there where we are trying to adopt and trying to consider. If you are able to capture the theory behind that particular algorithm in terms of the statistical models, it becomes very easy to you as a machine learning engineer or data science developer. You can easily capture, you can easily understand the kind of the algorithm. So it is a go-to method for binary classification, exactly like yes or no, true or false, all these kind of the things, like whether a mail is spam or ham, whether HR need to find out whether this person is going to join or not join. Okay, suppose 8 hours per day, if you are preparing, whether you can crack JE mains or not, advanced or something like that. So these things just gives us some kind of yes or no based kind of aspects, and we need to understand in what way logistic regression is paying observation related to this aspect. So logistic regression or logit. Okay, this is a logarithmic function. We'll come to that point, but we'll try to understand what is the analogy behind the logistic regression. So logit representation or logit model. It is a regression model where the dependent variable is categorical. Friends, here, if I'm talking about dependent, which is y, and independent, which is your x1, x2, like that. So we have seen some equation like y equal to beta naught plus beta 1 x1 plus beta 2 x2, something like that, some equation. So in terms of this independent and dependency, x1, x2, x3, all are independent variables, whereas your y is the dependent variable. Okay, so Just to find out this particular y, we are going to analyze the x1, x2, x3 values. Accordingly, we are going to get the outcome. Now, the dependent variable is categorical. Y is categorical. Categorical means yes or no, true or false. Okay, all these kind of the conventions belongs to the categorical. So logistic regression measures the relationship between a categorical dependent variable and one or more independent variables. This is nothing but x1, x2. This is nothing but your y. So what we are doing, we are going to establish a kind of the relationship between y and x1, x2, because we are having certain independent variables. So we are trying to get or we are trying to establish a kind of the relationship between y, x1, x2, and by estimating the probabilities using logistic function or logit function. One of the most important thing, guys, in the first scenario, first case, if you are considering, I'm having some values. Based on that values, I need to predict something. And here also I should give the value. Whereas in case two, I'm computing the probabilities. Probabilities means chances of occurring the event. And the prediction is also the probability. And now I can give some example, guys. Maybe exit polls. If you see, they generally give the chances. Okay, 30 to 40 seats, 90% of the chances are there. 40 to 50 seats, some this much amount, these many chances are there. Like that, they give the probabilities. So probability always gives the chances, friends. It's not the number, exact number. It won't give. Just it is giving the probability. Chances are more or less, or what exactly that thing. So. Uh, Especially if I'm talking about the logistic regression or logit function, it is rather than working with the values, it is going with the probabilities. And thereafter, it is used to predict the binary outcome given a set of independent variables. Okay, I'm having some set of independent variables. Okay, and of course, I am predicting some categorical value. So of course, we name that as a y. Okay, this is the dependent variable, and this is nothing but your independent variable. Okay, so like that, we are making use of the convention of getting the information from categorical and all these conventions, guys. Now, one more thing, if you refer, so this introduction is simple, is a way of convincing us why logistic regression is we are considering as a classification technique because of that categorical nature, because of that establishment of the probabilities, so as to come up with some kind of the predictions. And most importantly, this logistic regression is used to establish a kind of the relationship between two or more independent variables, one or more or two or more in the dependent variable, categorical dependent variable. Okay, so this is how you can refer. Now, in terms of the regression, actually, friends, if you consider the regression, already we have seen simple linear regression, multiple regression. Polynomial regression we'll see after completion of the logistic. In this particular logistic regression can be seen as a special case of the generalized linear model, and thus which is similar to the linear regression. Below are the key differences, because we should not get ambiguous while studying the linear and as well as the multiple linear uh, compared with logistic. So there should be some analogy on the basis we can observe, okay, this is the way how you can distinguish between linear and logistic kind of thing. So the predicted values are probabilities and therefore restricted through the logistic distribution function. Friends, a little bit probability specification. Just will refer the probability true and as well as probability of occurring and probability of non-occurring. So it is 0. It refers as P, it refers as Q, which is also known as 1 minus P. Only two possibilities would be there for the probability estimation 0 or 1. Zero is for the negative probability. One is the positive probability, in the sense we are getting true. We are getting maximum possibility of that occurrence. And this is the zero. There is no possibility of occurrence. So mathematically, we represent this particular probability of occurrence as P, and Q as the non-occurrence, and which is also known as opposite to that, 1 minus P. Okay. And in a way, your P plus 1 minus P. So just it should become 1. The probability of occurrence plus non-occurrence equal to 1. This is always satisfied. Now, if you are observing the other thing, guys, just how we have seen 0 and 1 kind of thing, the probability of non-occurrence and as well as the occurrence. Conditional distribution, already we have seen in the naive Bayes a conditional probability kind of thing, where probability of 0 for all x and probability of 1 for all x is a Bernoulli distribution rather than a Gaussian distribution. Let me show you what is the distinction between Bernoulli and as well as the Gaussian. 1 minute, guys. Bernoulli distribution versus Gaussian. Okay, so just I'm sharing the screen again so that you can also have the look on that, because this particular Bernoulli distribution is something like which helps us to observe the way how we are treating the probabilities, because though we are making use of the probabilistic distributions, but still we need to observe whether which kind of the distributions we are following, because many normal distributions are there, probabilistic distributions are there, and we'll see those kind of things also, friends, like the distributions at the specific way, like I can give some example, like in the metallurgy industry and as well as in the textile industry. Just what they do is they prefer some kind of the fixed sizes. Even if you are going to purchase some garments and all, we are having some XL X like that. We're having some fixed sizes. So how they are making, friends, due to that uniform distribution kind of thing. Okay, so if you are considering the distinction between Gaussian and as well as the Bernoulli, the trait theory consider, for example, introversion and extroversion as two extremes of a single continuous line. The population will be distributed in a Gaussian on the line type. Instead of considering introversion and extroversion as two poles of S-axis, the distribution will be Bernoulli. So if you are referencing these kind of thing in a more detailed way, so just if you go back and we're having some other options clearly, Bernoulli naive Bayes is good at handling Boolean or binary distributions. Okay, Bayes, already we have seen naive Bayes kind of thing that gives that binary or Boolean kind of aspects. Okay, Bernoulli. And whereas if I am having the multinomial, okay, Gaussian naive Bayes is good at handling continuous values based on that particular convention, because to understand the orientation of our probability theory, so just we are making use of the convention, like the probability distribution for zeros or ones. Okay, just we are true or false kind of the notation, as however we are trying for binary distribution only. Okay, and binary outcomes only. So and at times, guys, there is a possibility of verifying multi class specification also. That means I can say, I can give some example. Whereas if you are going to give some feedback about a product. Okay, so maybe yes, no, maybe kind of thing, or some sort of the sentiment analysis also we are having positive, negative and neutral, zero kind of aspects. So these kind of the cases would be there, guys. Okay, where there is a specific identification so as to handle the multi-class probabilities. So it all depends whether you are okay with but 90% of our use cases are binary only, like spam detection, whether that person is going to join in our organization or not. And if you are trying 4 hours to 5 hours, whether we can crack the exam or not. So yes or no kind of aspects. So these kind of the case studies really helping us so as to crack with the logistic regression, decision trees, random forest, and all these kind of the convention. But why this particular thing is specific is If you remember, guys, in the decision trees also, we have embedded the usage of the probabilities actually. So like we are making use of that entropy, information gain, and all these kind of considerations. And there we computed uh, some uh, some kind of the computation related to the probabilities, and we can observe that okay, on what basis we need to deviate that particular tree, what is the condition we have to check. So all those kind of the conditions. And one important thing, as a machine learning practitioner, whenever there is a chance of adopting the probability based kind of the theory, definitely we have to make use of that convention wisely, friends. Reason is it is always straightforward. Rather than telling directly this is the number you are going to get the thing, but rather I can say probability, the chances, so that very nearest thing I can predict. So rather if I am directly giving the number, it may or may not. Numbers always we should stand to that particular point, and heavy computings are required, exact predictions are required. But whereas in terms of the probabilities, we can always check that up to what extent we can achieve the prediction in terms of the probability. So otherwise, either you can with the hyperparameter tuning techniques, or else some other aspects you can perform the logics related to the requirement. And moving ahead, maybe you're having some doubt like, in decision trees or random forest or naive Bayes or support vector machine, even KNN also, we are having some sort of the applications. And can we have the applications related to logistic? So yes, of course, mainly email prediction, spam or no spam, and online transaction, whether it is a failure or not failure, and as well as customer churn, whether that particular customer is retained or we cannot retain. Okay, churn count. Maybe nowadays, telecom companies are suffering like anything, because the bulk customers are moving from one network to another network. So as to handle those kind of the convention, and as I said, HR status, whether that guy is going to join or not going to join, credit score. Okay, defaulter or non-defaulter, like credit scoring in the sense, just if that company. And nowadays, guys, one of the important case study related to this particular banking sector is, because so many cases we have seen, even 100 crores or I mean some crores level of the business. Okay, some 100 crore, 200 crore, 300 crore, they are not paying back. Okay, many examples we have seen. So nowadays bankings are applying these kind of the algorithms, and as well as they are monitoring the appropriate activities from 2 to 3 years at least, before sanctioning the loan, at least 900 crore or 1000 crore, like that customers would be there. But still, earlier we have seen some cases like in PNB and SBI. Okay, all those particular bankruptcy cases we have seen. So now they came up with the analogy. So like they are asking many things. Okay, who are really requiring that heavy amount of the loans. So all these kind of the conventions are better with the logistic regression, as comparatively, guys. In the support vector machine or naive Bayes, though we are using the probabilities of the Bayes theorem and all, but this logistic probabilistic estimation is a bit easy. I'll show you that equation, occurrence and non-occurrence, and how it is getting that particular logit function, because that is the base for this thing. Otherwise, how we are making use of our a linear regression implementation, multiple linear regression kind of the implementation. Similar way we are performing the activities. And why I need to use the logistic regression? So, friends, here interpretability, because after implementation, maybe your team member or maybe even client also want to understand why we have specifically used the this kind of the model. Because one important thing, model or algorithm, whatever you are selecting, they should be in a position to observe, like, you should be able to explain the things. Okay, explainability, interpretability must be there, guys. So though the algorithms are very efficient, but still you need to be in a position to explain to the users also. and output are well calibrated because they are all probabilities. So you can proudly announce and all the things you can do without any hassle. And model training and predictions are fast. Okay, friends, here, if you consider the KNN, okay, it is the fastest algorithm. And then this particular thing also, your logistic, as we are talking about the probabilistic values, it is also very easy and very easy to implement and as well as faster also. Now, this is having some comments, friends. Actually, features don't need to scale, but still we are scaling some of the features, guys. Like and maybe their thought process is like this. However, we are using the probabilities, but we need not depend on the values of the corresponding features, so that we cannot take that thing into the consideration. But practically, guys, no matter whether I'm using the logistic or decision tree or whichever the classification technique, definitely we prefer to engineer the features because all features may not be suitable to implement or all features may not be suitable to our algorithm. In that case, the missing value imputation, encoding techniques, and feature engineering we have seen in the earlier sessions, like standardization, normalization, all these things, and can perform well with small number of the observations. And there are certain cases, guys, like if I am having limited number of the inputs, if I'm having the limited number of the records, so as to implement my algorithm, some algorithm may not predict perfectly. Okay, at the training they are good, but at testing we may get some kind of the deviation. Okay, so but those kind of the things we can avoid with the help of the logistic. So comparatively, this feature and as well as the interpretability feature, these two are most important and connected features as a data scientist. Okay, so just you can make use of this thing, and at the level of study of that particular case study, you can adopt these kind of the methodology. But what is the problem with a logistic? Because we should be practical. Like at the moment we are judging. Okay, this algorithm is good, and at the same time you should see the limitation also. And performance is not competitive with best supervised learning methods because at the moment I am talking about the classification, friends, immediately decision tree coming into the picture or random forest coming into the picture or else support vector machine. And if it is the text classification, I can go with the naive Bayes. If it is the distance measure, I'm having the KNN. So such kind of immediate the connect for the machine learning engineers won't be there with the logistic because whenever there is a requirement of probabilistic analysis and explicitly if you decide, okay, I want to go ahead with the specifications of the logistic kind of things, probabilities and all, then only we are going to make use of this thing. Okay, because that obviously, and still some other aspects are also there, guys, like in the earlier examples, if you remember, in the missing value imputations, if I'm using the logistic regression, okay, in fact, imputing the missing values can be done with the logistic regression. So we have observed some good performance compared with other aspects. It all depends on the data set also, guys. But overall, apart from the data set, the algorithms are having certain kind of the features and advantages. Okay, so if you consider that kind of the advantage, this logistic regression from the research and from the studies showing that this is not computed with the best supervised uh, algorithms, okay, or methods, whatever we are talking, like decision tree, random forest, and all those kind of the conventions. Moving ahead, and most importantly, what is the key factor? What is the success behind the logistic regression is this particular function, guys, actually. If you observe this thing, we'll try to examine this particular specification. As I said, there is a concept called logs odd ratio. Okay, logs odd ratio is nothing but probability of occurrence and probability of non-occurrence. Just now I have said P is a positive occurrence and Q is a negative kind of thing, non-occurrence. And this Q can be represented as 1 minus P also because the flexibility with the probability is that one only. Now the probability to log of odds ratio. Okay, so why be the primary outcome variable indicates success or failure, true or false, or 1 or 0, and probability values. Okay, probability of y equal to 1 and probability of y equal to 0. Um, and now just we need to find out these kind of the considerations, y equal to 1 and as well as the y equal to 0, given 0, given 1, like that. And x1, x2, x3 is a typical representation for the independent variables. Nothing great, guys, because though it is a classification kind of thing, the way we are understanding this particular thing is in terms of the regression. If you consider the regression equation, we are having this thing, na? Beta naught, beta 1x, x1, beta 2, x2, like that. We are having some kind of the equation along with the error term. So similarly here also, just we try to substitute these kind of the conventions related to the probability of occurrence and as well as the non-occurrence. So the odds ratio, as I said earlier, it is a true, and this 1 minus p is something like which is opposite condition for that event of occurrence and event of non-occurrence. So the logit function, this odds ratio, just we are applying the logarithmic. One important point, guys, here. Uh, Actually, if you are referencing the probability, yeah, so that we can compare the logistic versus the decision tree or support vector machine or naive Bayes kind of thing in such a way that along with the probability theory, we are using the logarithmic aspects also. Very minute or detailed aspects also we are studying. Whereas what is missing in other implementations, though they are using probabilistic analysis, is this point only, guys. So after getting the probabilistic analysis, again we are picking up on the logarithmic values, which is giving the exponential understanding. Like exponential generally we overlook. Okay, just e power something, and we are not considering those kind of the aspect. But the logit function allows us so as to focus on these kind of the aspects, like applicability of the logarithmic on top of the probability of occurrence and non-occurrence. And this is as a whole call, we can call as the odds ratio. Okay, logs odds ratio, like that we'll say, because your odds ratio is something like p versus 1 minus p, and applicability of the log, and it is also known as the logit function, your logistic or logit function. Due to this particular thing only, we are getting this term logistic. That's what in the beginning of the session we have seen that your this logistic is borrowed from statistics. Okay, if I'm considering the decision tree, it is from data mining, actually association rule mining, from the data mining, and your gradient descent and all, again from calculus and derivatives. Some or other way, just we are deputing these terms and we are adding our flavor related to the understanding of the algorithms, friends. Okay, so always we need to get the background of this methodology, okay, with respect to the mathematical and as well as the statistical things. If you go ahead with that, but only the thing is, the good news is you need not remember all these formulas, but only the thing is you need to understand these things. You need not memorize. Okay, only the thing is what is the logic behind this, because in the calls and as a lead or else as a kind of the senior member, if at all you need to I mean you are knowing that like this logistic regression is definitely giving better results in the implementation. Maybe your senior or maybe your junior may ask why I need to go with the logistic. More or less your implementations are same. Okay, there are only one or two changes in the implementation. Now you can come up with this analogy. Okay, rather going with the explanation of the code, because code, if you consider the scikit-learn and all, they are all having the same kind of the flow, train test split, and thereafter importing of the corresponding algorithm, and then fixing that particular algorithm, and thereafter the prediction, like that, fitting the algorithm and then prediction. So this is a flow and certain metrics we are having. So in every algorithm we are following the same kind of the template. But if there is a debate and if at all you need to explain to the detail, then these kind of understandings definitely give the edge, friends. Okay, and one more thing, especially in the Databricks certification also, machine learning very less resources we're having, friends. I mean, in terms of exam, I am talking about. Otherwise, we're having many blogs and many contents we're getting. So that's what I'm posting day to day kind of the learning, so that it creates some kind of learning curve for you. Maybe 15 to 20 minutes read those particular postings. Because every week, if you are talking also, maximum we can talk at only one algorithm or one topic. So I thought of maybe let me post these particular things on a daily basis, so that if you guys are having any doubt, then you can reach me so that I can clarify. So like that we are managing. Now this logit function, just as a substitution, guys, uh, just exponent of this beta naught b what beta 1 x1 and beta 2 x2, like that. So it overall gives that the understanding of the p value. Okay, like that. So now the point here is what it is trying to explain is actually probability of occurrence. Na? P value is nothing but probability of occurrence. In that particular case, just as we are using the logarithmic aspect and as well as to convert that into the exponentation, we are thoroughly getting the narration of. Thoroughly, we are involving all the independent variables, and we are making use of all possibilities to understand, and we are exposing these particular variables um, um, to our model, so that obviously whatever the features we are giving, whatever the things, exactly it is trying to experience all these features. See, friends, here one simple thing: if you are succeeded to narrate the information or narrate the actual values of that features, then you are done. Because algorithms or model, what they are trying to do to understand the data, and after understanding the data only, they are going to publish the results in terms of metrics or measures. So if you are able to maintain this particular convention, and if you are able to convey the complete information about the algorithms, complete information about the data with the mathematical notation. Why we need to use the mathematical notation is this is even in PhD or in your MTech also, maybe in engineering also, to defend your results, so as to exploit your results, we have to quantify that. Na? So maybe your algorithm is good or your project is very well, but how do you compare that? How do you show, okay, like these are all the test cases we ran, and this is the how this is how we got some kind of the betterment, this percentage of the betterment we got, like that. So always mathematical or statistical measures are really helping us in terms of proving our point without any deviation. So here also, why still we are using logistic regression with these many log odds ratios or exponentation or usage of the logarithmics with respect to the probabilities, because it's a multifold kind of the understanding. Okay, obviously, if you are focusing more, if you are analyzing the, if you are giving the chance to understand your features by the algorithm, then your model is powerful. Okay, because though you are doing the data pre-processing, all these feature engineering and fine tuning of the parameters, but ultimately understanding of the data set by the algorithm is the most important part, friends. Okay, for that particular purpose, that is what the reason the inherent mathematical or statistical methodology helps the algorithm so as to process the appropriate features in the better way. And once that particular process is through, then we are done with the observation of the data. Okay, now what else? So the other points where I can pull into the discussion is the logit function and as well as measures of this particular thing. So now you can easily connect the dots, friends. Okay, once this thing is established, now have a look on this. Just there are two kinds of the conventions here. What they are trying to do is suppose if you observe, guys, in terms of your linear and multilinear regression, we always trying to get this kind of the value. Okay, maybe x and as well as the y notion. So just we are trying to get some best fit line where this particular line is used to establish a kind of the relation between x and y. But this is what you call the best fit line or regression line. Now, practically, friends, you observe if I am drawing some sort of the values like this, if I'm trying to fit this kind of thing, it is something like going in this way. Okay, it's never been a straight line. But whereas our assumption in linear or in multi is these kind of things are straight line kind of thing. What we are doing, just we are trying to establish a multiple line kind of things, and we are trying to reduce the errors. Okay, with ordinary least square errors or all these kind of the things. But the practical implication of this data set, that's what I said. The points are correctly represented in the logit function, guys. That is the main advantage why we are preferring logistic regression compared with the other models. Okay, in terms of linear and multilinear, always we are in the assumption. Assumptions are most important, guys. We are getting 2 to 3 questions apart from these regression topics. Assumptions probably I'll post. I have posted in the yesterday's day wise preparation, but I will cover those things in the next week. Just to go through that because the assumptions are these regression models are parametric in nature. Those particular models, parametric in the sense we are having some assumptions. Okay, maybe multicollinearity or else dependency among the independent variables, heteroscedasticity. Like that, we are having certain assumptions in that. Whether they are true or false, we are not bothering. Just we are as a habit of parametric kind of thing. We follow the same convention of the assumptions in the regression models. Similarly, in this particular linear and multilinear, we are in the assumption of okay, the best fit line, and as well as according to that line only, we are performing some sort of the activities. Okay, but here you can observe the functionality, guys, here. So it is clearly mentioning that how I am making use of estimation of probability of occurrence and as well as the non-occurrence logit function, actually P and as well as the logit of P uh, purely, so that these values together gives the a line of understanding. So the relationship is also reasonable. I mean, it's not something like assumption, or it's not something like is a virtual or a hypothetical kind of thing. Rather, what we are doing, we are stick to this particular line, okay, a shaped kind of the curve, where this particular curve is exact representation of these probabilities and all, which is missing out in linear and as well as the multilinear. So this is how we are preferencing the usage of the logistic kind of thing. With the help of these kind of the conventions, one can easily refer, and you need not remember all these things, guys, like the pi and as well as sigma. These are all common notation, summation, and as well as the product kind of the notation. Of course, if you observe the probability of occurrence and probability of non-occurrence, here also probability of occurrence and non-occurrence. Just here we are focusing on the product pi, whereas here we are focusing on the summation. Individually, we are applying the logarithmic aspects. Okay, and the way we are observing these things is just have a look on this logit function, guys. Logistic regression is an estimation of the logit function, logit p by 1 minus p of log, and logit function is simply a log of odds ratio. This is the odds ratio, guys, 1 by 1 minus p in favor of event. This function create a S-shaped curve with the probability estimate. Okay, the reason always said, guys. Okay, like if you are focusing more detailed, suppose you are attending some meeting and you are asking more questions. So obviously you will be getting more information. Rather you are listening to them and you are okay with okay whatever they say, then there is no value add. Similarly here also, if you consider the linear and multilinear, hardly what they are doing is they are nearest locations only we are touch basing, and of course it is always a straight line kind of thing. Whereas at the moment you are talking about this S-shaped or logic kind of thing, they are to the detailed, and just they are making use of the exact position, and accordingly they are drawing this curve. Okay, so these are all some of the things where you need to observe in the logic. And coming to the metrics, guys, many metrics we have seen, no matter there is no separation. If you consider the metrics or measures in terms of our classification, especially as we are talking about the classification, always guys, confusion matrix. This is one of the important thing. And from this confusion matrix, you can specify the accuracy, precision, recall, and then we are having some F1 score, sensitivity kind of thing. And thereafter we are having some uh, yeah, these k-fold cross validation and all for the fine tuning guys actually. K-fold cross validation, grid set CV, and these are all some of the methods where you can elect, where you can opt so as to empower our algorithm. AUC, ROC curve, all these kind of the notions, not much differentiation. Okay. AUC, ROC, confusion matrix, accuracy, precision, recall, all these kind of the conventions. Based on the requirement, you can opt whichever, but definitely we are getting some sort of the questions in the metrics also, guys. Can someone help me? Which are all the metrics for the regression, by the way? Okay, so just we are having the regression RMSE, root mean square error, root absolute error. As a machine learning practitioner, you should know all these things, guys. R square, adjusted R square. Okay, these are all the flavors of various measures of regression, metrics or measures. Um, in terms of classification, as this is belonging to the category of classification, just we can make use of that specificity, sensitivity, F1 as a byproducts no? For the confusion matrix, just they are all byproduct. And k-fold cross validation. K-fold cross validation, grid set CV already we have seen in the beginning of the sessions, guys. If you want to have that, just to use the repository. We have placed all our recordings in the repository along with the class shell also. Okay. Right. And what else we need to see? So some other options I compiled for us guys so as to study because in some kind of the cases we are having the observation of some more statistical measures. Those particular statistical measures, let me give it to you. So 1 minute guys, just I have compiled for us. So these particular thing are purely over and above. Okay, because just I want to notify you, and if any such kind of the measures are of course if you come across these kind of things, just we need to have the notion. All these things are especially in the logistic kind of the discussion, as we are talking about the probabilistic analysis and we are striving for betterment compared with other regression models. These are all specific techniques for logistic regression only. As I said, na, so in the team meets or if you need to defend why I am going with the logistic regression, then see guys, all the decision trees, random forest, there, whatever the metrics I have said in the above, like, you know, all these are the metrics and measures common for your decision tree, random forest, and support vector machine, naive Bayes, and KNN. These are all common. But whereas specifically, if you want to utilize any of the metrics related to the logistic regression, because you know, if I am following a different path, my estimation and my I mean, whatever the way you are seeing me should change. So that is how you can change over between normal classification techniques. Normal in the sense I am not disseminating. I mean, I'm not degrading that. Other classification techniques. Only the thing is, guys, why we are focusing on the logistic especially, and why I kept this particular logistic discussion as a separate model is it is having its own advantages, like probabilities. On top of that, we are applying the logarithmic functions and that logit again exponentation. So it's a kind of a granular. It's a kind of granular so as to convey the information to at a detailed level to our algorithm. So if you are able to convey the information to the algorithm in a proper way, if algorithm understood the data in a proper way, then we can expect the better results. So exactly from the background of this logistic regression, we got the same essence. But apart from that, one more good news is along with the above mentioned classification matrix, we are having some other fine-tuned measures or metrics available for the logistic. Okay, maybe we are seeing these things first time, but I strongly recommend you guys just have a look on these kind of things where these things may help us to crack the exam in more confidently. Okay, so omnibus test of model coefficient, which should be value should be less than if it is 0.05, helps to reject the null hypothesis that there is no difference between the model with only a constant and the model with the independent variables. Actually, there is a concept of hypothesis testing. Okay, this particular hypothesis testing strongly dependent on the p-value. And if p reaches to a certain value, then we are going to reject that. Otherwise, we need to accept that particular hypothesis. Okay, so if you are referencing the omnibus test to so as to test the model coefficient, coefficients friends, like just beta naught, beta 1, COE computing already we discussed in the linear and as well as the multilinear. Just go and have a look on the recording. And walled statistic. This is also like how we are having the jet test and all these kind of thing equivalent to the t test kind of the statistic in regression. T statistics used to check the significance of individual explanatory variable. Individual variable. Okay, rather focusing on a combination. If you are having some doubt, maybe this thing is really adding value to my data. Okay, sometimes though we are having 15 features, one feature may be guiding us to one feature is highly influencing our outcome. Maybe sometimes the person's selection list in the team India, maybe his strike rate, or maybe his qualities like hitter or all rounder. Okay, like guys, some of the features may be highly influencing in the selection process. If all rounder generally, the selectors, I mean, the selectors also attracted to opt those kind of the members. Reason is simple; they can be used for both the ways. So here also, if you are referencing this statistics, it is checking the significance of the individual explanatory variables. So if the p-value corresponding to wall statistic is less than 0.05, the coefficient of the explanatory variable is not 0. Okay, and this thing, guys, it is typical test, which is Hosmer-Lemma test. Okay, Hosmer-Lemma test. What it does is the test for overall fitness for binary logistic regression. Okay, overall how all these together. Maybe individually, if I want to check the variable, then you go with the walled statistic, especially in the logistic. Whereas if you want to test the coefficient, test the model coefficient, then go with the omnibus. And this thing, just if you are considering Hosmer test for overall fitness for binary logistic regression, if p-value is less than 0.05, signifies bad fit for the model. Greater than 0.05 is nothing but model can be accepted. If at all you want to venture some additional things. Why I'm covering these things is, guys, I have seen that some questions were there in these lines also, because this is a specific topic and you can able to answer all your accuracy, these specificity, all these things. But whenever any question is there above and beyond this particular logistic, then we should be very cautious, guys. If I need to test overall, then I need to select the Hosmer-Lemma show. Whereas if I want to focus on a single value, then I can go with the walled statistic. Otherwise, if I want to focus on the COE coefficients, then I need to go with the omnibus. And we're having the likelihood ratio also equivalent to F test actually. Used to test the null hypothesis that all the slope coefficients are simultaneously equal to 0. This is a typical situation, guys. Like, the slope value becomes zero every time, then it all leads to a zero kind of thing. Then in that case, deviance d minus 2, which implies a log of likelihood. The same problem is there in some other thing also, guys, where you need to add that 1 so as to avoid that particular zero kind of aspect. So in such kind of the cases, in those particular thing, you can go ahead with the likelihood ratio. Okay, measures the deviance from the perfect model. The larger the value of d, the worse the fit. Obviously, no, just it is something like error. And the p-value corresponding to d is less than 0.05, the overall model is accepted. Okay, if such kind of the slope value becomes zero, then entire product of that particular thing is zero. Then we cannot say that where do we stand actually? What exactly our model is giving. And now one more thing, guys. Actually, R square and adjusted R square, they are purely for the regression kind of thing. Now let us see. If you are considering conventional measure R square is not meaningful, different R square statistic prevalent, where Fadden introduced R square value at 0.20 and above is considered as good, and Cox and Shell R square implemented negative R square. Actually, these R square discussion, guys, we have seen the problem with the R square is it is not focusing on the features who are negatively contributing. Negatively in the sense, guys, I mean to say maybe we are having x1, x2, x3, x4. And if I am adding all these things, maybe I'm getting 89 percentage of the accuracy. If I'm removing X3, I may get 91 percentage. I may in the sense this particular X3 is killing. And I have seen one case study, friends. Actually, you might have seen that newspaper ads, radio, and as well as the TV ads. And here the process is we need to study individually and as a combination whether our sales got increased or not. In that particular case, guys, it is pretty simple. Nowadays, newspaper and TV are more crowd pullers. But if you consider the FM kind of thing, or all those things may not influence that much. Okay, especially in the medical domains and all these things, because particularly in the olden days, okay, maybe in 90s and that time, okay, the people only go with newspapers. Okay, and that time radio is more popular, so that if any announcement is there for that, then definitely it is capturing the attention of because more audience and more customers are there for that radio. Obviously, it is influencing the sales. Nowadays, only just while traveling, or we kind of people while traveling to the office, maybe we are playing the songs and all, and we are not interested to listen to the ads also. Simply we are changing that particular station and all, we go to some other specification frequency. So here radio ads nowadays are not going to pull those many sales, okay, according to a study. So if you are removing this budget, I mean to say removing radio means this budget, so obviously we are getting the proportionate sales in a better way, because whatever the budget I am incurring on these three things should maximize the sales. But unnecessarily, just we are putting the budget on radio advertisement, but it is not reflecting that much into our outcome. So this is what how we can manage the things related to the logistic regression, guys. Just let me give you a key takeaway. Initially, we started with the discussion of what exactly the logistic. Here there is a logit function, and just it is trying to establish a kind of the relationship between categorical data and one or more independent variables. And regression wise, guys, just which are all the suitable applications. We have seen some sort of the applications. Advantages wise, well, with the small number of observations also you can depend. And one more thing, the probabilistic analysis, because it is having the usage of the odds ratio, logs odds ratio, along with the logarithmic estimation, and we are making use of that exponentation, all these kind of thing. So the ultimate goal here is the ultimate point we need to observe is every detailed we are conveying to our algorithm. If it is successfully if your mathematical model or if your logic function is successfully explaining the things to your algorithm, then if your algorithm capture all the possibilities or flavors of the features, then it is easy to predict the things, guys. If you are preparing well, if you are well prepared for the client call, maybe in terms of the presentation, and you know that whatever your team members are doing and how we are involving in the task, then we can easily go and proudly present in a cadence call. So similarly here, just every detail this algorithm is conveyed. So obviously for the algorithm, it is not difficult to predict the better things. Okay. Now here, these particular equations, the possibilities, okay, maybe with the summation or maybe with the product based also, we can manage probability of occurrence and probability of non-occurrence. In fact, that is a probability of occurrence and non-occurrence, that is the log-Sart's ratio. On top of that, we are having that logit and of course exponentiation as a derivation kind of thing. Most important point we need to observe is especially while explaining to your teammates why should we use this logit. Then there are certain possibilities, guys, where along with your typical classification metrics, you can make use of other metrics also, like omnibus for the COE and world statistic so as to explain individual explanatory variable, and Hosmer test for the sake of overall fitness of the corresponding binary logistic. And suppose if something happened, maybe the slope value becomes 0. In that particular case, how do I handle with the help of the likelihood ratio? And especially the adjusted R squares and all these things are definitely helpful so as to maintain, which are really contributing to our thing. R square and adjusted R square, there is a slight differentiation, guys. R square is unable to fine tune the appropriate features which are not really contributing. We have seen some example here, but whereas your adjusted R square is wise, so it is thoroughly investigating each and every feature, and it is making use of it is picking only the features which are really contributing to our increase in the prediction rate. Okay, so these are all the aspects and just my suggestion, guys, just you have a look on these omnibus and as well as Hosmer and Lemessey test, and thereafter this other thing is there na likelihood ratio. Have a look on those kind of the things. Uh, Along with that, have a look on this assumptions in. We are getting many questions from these things, guys. Assumptions in regression. Okay, I have posted this thing actually. So, but still, however, in the next session we are going to cover. And in the meantime, if you are having any doubts, guys, please reach me out so that I can resolve those kind of things. Okay, and in the along with those kind of things, I'll be posting some questionnaire also related to the Databricks examination. If still you need any support, like in terms of more questions or more topics, please reach me out so that I can post those things also. Okay, thank you. Okay.